On section 3.5, we're going to do example 3. I do want you to take just a moment to go to consult your electronic notebook and put in it the parallel lines theorem. And what that states is that in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. We learned this in algebra. It has a geometry component here. It's a theorem, parallel lines theorem. Lines are parallel if they have the same slope. If they have the same slope, the lines are parallel. It works both ways. And also tack onto that, any two vertical lines are parallel. All vertical lines are parallel to each other, okay? Here's your other one, perpendicular lines theorem. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. We learned that in algebra last year. We called them opposite reciprocals, as you may recall. And if you multiply opposite reciprocals together, they equal -1. So that's the math behind it, opposite reciprocals. I think we did, like, if you had one slope is 1/3, the other one is going to be -3/1. If you multiply them, you'll get -3 over +3, which equals -1. So that's a great test, is if you can do it one of two ways, or you can do both ways. You can go, hey, I see that the slopes are opposite reciprocals, or you can multiply them together and make sure they actually equal -1, okay? Vertical and horizontal lines are always perpendicular to each other, okay? Always, 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 okay? So let's take a look. This is more information about the opposite reciprocals that I just mentioned. I use numbers because sometimes variables can be confusing. All right, example 3, determine whether the lines are, you have three choices, parallel, perpendicular, or neither. What are you looking for if the lines are parallel? Right, same slope. What are you looking for if they're perpendicular? Opposite reciprocals, or when you multiply the opposite reciprocals together, they equal -1. Good job. And neither, they're two different slopes altogether, okay? So we've got two lines. Look at letter A. We have two lines, line AB, which is in red on your video, and CD, which is blue on your video. And they've given us all the points. Now, the reason why they're giving us all those points is because they want us to use a slope formula. You guys know how I feel about that, especially when we have a graph and all 4 points are at a grid intersection. I am really comfortable with just using rise over run for both, okay? So I'm good. If you're good with that, I'm good with it. So let's start with line AB, and we're looking for the slope. We're going to do rise over run. I'm going to start down here where A is, and I'm going to go up 1, 2, 3, 4. Okay, so I went up 4, that's positive. I'm going left 1, left is negative. The slope of this line is -4. It should be negative, it's leaning to the left, so I'm doing it correctly. Okay, now let's do CD. And we're going to do the same thing. I'm going to start down here at D. I'm going to go up 1, 2, 3, 4. I went up 4 and left 1. And it also has a slope of -4. So because of the parallel lines theorem, which states that if they have the same slope, then they're parallel, these lines, I can certify that these lines are indeed parallel. Guys, sometimes they're going to throw up there, on your graph, they're going to put lines that look really close to being parallel or really close to being perpendicular. You cannot just eyeball it. You've got to let the math drive this answer. It is essential that you do that, because I've been tricked on some problems before, eyeballing it and going, they look like they're parallel. And I'm guessing instead of letting the numbers drive it. So let the numbers do the work here. All right, let's flip the page. All right, so we've got ST and UV. They're crisscrossing, so definitely aren't parallel because they're intersecting, so we can eliminate that. So I'm going to do rise over run again. So let's start with ST, that line. That's the red line in the video. We're going to do rise over run. We'll start down here at T. I'm going to go up, 1, 2, 3. Okay, up 3. And then I'm going to go left, 1, 2, 3, 4, 5, 6, 7. Left 7. Okay, so the slope of this line is negative 3 7. So it doesn't matter where the negative sign goes. It can stay with the 7. It can go out in no man's land, or it can go up with a 3. The point is, this is a left-leaning line, which means the slope is negative. That's the point. All right, let's do the blue line. Let's do UV. Okay. So start down here at V. So let's go up 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8, and I'm going to go to the right 1, 2, 3, 4. Right 4. Up 8 over 4. 8 over 4 is 2. Do those appear to be opposite reciprocals? And the answer is no. The slopes are not the same. And so the lines aren't parallel, and the product of our slopes does not equal negative 1. If you multiply 2 times negative 3 sevenths, you're going to get negative 6 sevenths. That does not equal negative 1. So I would have to classify this as being neither, not parallel, not perpendicular. It's neither. Okay? Let's take a look at letter C. We'll start with the blue line. Okay, so it looks like we've got HJ. That's the blue line in the video. So I'm going to go up 1, left 1. Up 1, left 1. So my slope is actually negative 1. Okay, and let's do the blue line, or the red line, excuse me, FG. I'm going to go up 1, right 1. Up 1, right 1. That gives me a slope of 1. Are those opposite reciprocals? Yes. Do they, when you multiply them, do you get negative 1? Yes. So guess what, guys? These lines are perpendicular. Okay, I think my way is a lot easier than doing the slope formula, but if you're not comfortable with the slope, or with rise over run for whatever reason, use the slope formula. That is always an option, but do not eyeball it. Because if you had eyeballed letter B and said, yeah, those look pretty close to being perpendicular, you would have gotten it wrong. And letter C, actually, those are perpendicular lines. So the numbers drive the answer. That is, if I can emphasize that, I don't think I can emphasize that enough. All right. I don't have any bonus for you on this one, but we'll practice this in class tomorrow. Thanks for listening.